Hey, so I want to make this video on doing a quick project for you. And the first thing I want to show you is what integrated development environment, or IDE, I'm going to be using. I'm going to be using PyCharm. The way you download it is just going download PyCharm on any browser. And I'll be using the Community Edition. If you're on Windows, it'll look like this. And it'll just say .exe. Download that. I already have it installed, so I'm going to go over here and just start working in it. And after you install it, it should look something like this. We're going to make a new project, so we're just going to double click that. I'm going to full screen here. And we're going to make War today, the card game. So I am going to name the project War, and then I will select my Python version. I already have Python installed in this location here. If you had more Python versions installed, you could select it from here, and this will be the interpreter that is used when you actually run your code. And you can see here, we'll make a virtual environment with venv rather than conda or some other environment. And we could also do stuff here like making a Git repository really quick, or we can do it later in the command line. We'll hit create here. And first thing you'll notice is, well, there aren't any Python files, but we do have our venv folder here, which will hold all of our packages that we install, if any. And this is just our root file for our project. When you want to make a new file, you just right-click and then File. We'll name it. We'll just call this main.py. And here we go, ready to go in our first file. And just to do a simple sanity check, we can always do, run it from the main function. We can do if name equals main, and then we can just print hello world. And then an important thing about PyCharm and other integrated development environments is coming up with something called a configuration. In VS Code, it might be named well, in VS Code, it should be setting up your debugger settings.json. Actually, I think it's called launch.json. Here, since we're using PyCharm and many other JetBrains IDEs, you set up a configuration, and you do that here in the top right corner. Right here, you see current file. So if we were to press the debug button or the run button, it's just going to run whatever is in the file we're currently looking at. But if you have multiple files and you want it to run the same thing every time, you can make a new configuration by first clicking on current file and then make new configuration. We'll add new run, Python, and then you can see here we can name it, we'll just call it main, and we're going to run with the interpreter that we set up at the start in our virtual environment, which you can see .venv bin Python. If you're on Windows, it'll be .venv script. It should be, scripts and then python.exe, I think. If we want to, or here's where we select like what file we want to run. So I'll just open up the browser right here and, well, I'll just type it in. I mean, I already know what it's going to be. It'll just be main.py. And if you wanted to add any parameters like command line arguments, you could do that here. And we could choose our working directory. I guess I'll just find it. I don't even remember where we are. Yes, PyCharm projects. That did not work. PyCharm projects, war, and that'll be where our working directory is, and I guess I'll just select that here again for this main.py is what we want to run every time. So now it's the full path, so in case you were to run it from some other directory, it would still work correctly. And if you had different environment variables, you may see them sometimes in our virtual environments, you may sometimes see them .venv as we have here, or .env. They both are the same thing, just different naming schemes. You can select that path here if you want to use a different environment variable. Sorry, excuse me, I keep saying environment variable. I mean virtual environment. So we'll apply that here, and then typically you always just run with the debug. So we'll run debug, and we see it finished successfully. We get hello world printing to the console, and life is good. So that means that our configuration is set up properly for the main function, or, the main file where we're going to write our main function, and we'll start building from here. So the first thing I want to do is create a card class. So what I'm going to do here is make another file. General wisdom says it's good to kind of split up your classes so that your files don't get too large. So all I'll do is card.py, and first we'll do a class card, and then we're going to set up our initialization function. So that always goes def underscore underscore init underscore underscore and then self. So self is a keyword that denotes what the current object is and its attributes and methods. So when I'm using methods inside of this class, this card class, aka the card object, we can use the self parameter or the self keyword dot something, and that's how we can access attributes within the actual class itself. So let's say we want to take in a color. So for the card we might have a color. For the card we will have a rank, and we'll also have, we'll say we'll have a suit. Obviously the color is dependent on the suit, but let's just say for here that's what we want to add. So these are parameters, but we want to set them as attributes to our card class. So what we'll do is we'll do self.color, we can name this whatever we want, equals color. So that will set the attribute color for the card class to whatever we passed into the initialization function. And I'll show you how to use this later. As mentioned though, we could do self.rank card for example and do equals card, or rank, excuse me. That doesn't matter necessarily. We can use whatever name we want for our attribute variables, or whatever name we want for our parameters, of course. But I'll just keep it the same name for simplicity's sake, and then we'll do self.suit equals suit. And now these parameters will be passed into this object's attributes. So now after we reference this attribute later on, we know exactly, what its rank and color and suit are. And it's always good to document your code. In Python, single line comments are just with a hash, so you can, this is a comment here, and then you can also do multi-line comments by either doing a triple quote like this, which it pulls up the doc string. I'll explain that in a second. Or you can do triple double quotes, and also is the same thing. The reason why this works is because the interpreter was never designed to read information between triple quotes. So they kind of just assumed that this is the way to do it. There is no actual official way to do multi-line comments in Python. And you'll see a lot of people who do multiple comments like this, and other people will only do comments like this here. It all is just personal preference. And then, like I was mentioning, there's an idea called a doc string. So a doc string is just kind of like a description of what the parameters are and what this generally does. So we may say something like, this creates an instance of the card class and sets the, I guess we call it cards attributes. One thing to note is that the common notation for classes is that they're always capital letters for each new name. So if you were to have another class down here, let's say class card, I don't know, let's say, how could we do this? Something with multiple names. Card 2, sure. And if we're using two different words, this second character would be still capitalized, or the second word's first character will still be capitalized. And of course that carries for the first word as we have up here. So, and then for the rest of the doc string, we can talk about the color would be color of the card, rank of the card, suit of the card. And of course, this is pretty generic, so it doesn't want to, it doesn't lead very much information, but in the case that you have complex parameters, it's always good to document what you're doing. And then we can make we can make methods in this card class by being indented with inside of it. Of course, as you see here, this initialization function is indented. We can make new methods. So let's do, what I like to do here is I always like to do getters and setters, aka how we can change these parameters here, the self suit, self whatever, or we can get the value that's currently associated with them so that we can keep the scope of these variables relative to this class, meaning that we're not directly accessing them, we're using methods to access them so that the privacy per se of that stays relevant. So we'll just say like getters here, and then we can just copy this, and we can do, you know, setters here. So we'll just make some getters and setters really quick. One really cool thing is, this is sort of a specific thing to JetBrains IDEs, is that you can actually generate them. Sort of a hack, but you can make, or maybe that's only specific to Java stuff. Not too sure on that, but obviously you can always make them yourself. Another notation thing is that typically methods that are within a class will always have a leading underscore in front of them. So if we want to make a getter method for getting the current value of color, we might do get color like this, and it's going to lead with the underscore. You'll see that PyCharm automatically populates the self keyword. The self keyword has to be always within every single method of a class's method list, right? So this always needs to be included, regardless of if you use it or not. If you don't use the self keyword, doesn't matter. If you do, obviously it needs to be there. And you know, if you aren't using the self keyword, well, that would be when you'd make something out, you know, out. It's called foo, right? You'd make a global scope function that is relative to this file, because you don't need to access class specific information, right? So go back to our getColor method, and here we just do return self.color, right? Because we want to get this color attribute from our class. Let's do this again, def, you know, get rank, automatically populates for us, very nice. I'm so used to typing it by myself from using terminal-based editors that I sometimes accidentally type, even when it's doing it for me. Of course, you can make doc strings here by just doing your triple quotes or double quotes, whatever you want. And here, of course, because we are returning something, we could talk about what we're returning. I'm not going to do that just for time's sake, but of course, more documentation is never necessarily bad. And we'll make some setters here. And we want to pass in a color to set. So you can think about these almost like what you saw up here, right? We're setting them individually here. But it's always nice to have these getters and setters just to make things a little bit more readable when you're actually programming with this specific class. Okay, so now we have getters and setters, and these are always just nice to have. It's not necessarily needed, but having them is always good, just for readability's sake, like I was mentioning. So now there is the idea of using what we have here in a separate file. The correct naming for another file would be a module. So if we're in our main.py file, the card.py file is considered a module. So this would be the card module. So if we want to use information from the card module in the main file, we would need to import it. So there's an import keyword, and let's say that we want to import, you know, the entirety of the file. You could just do card. You don't need a .py because it's considered a module, not a file. It's not something like, you know, in C where you do include, you know, something here like header.h, different than C or C++ for that matter. You just import card, right? And now if I wanted to use card, like I want to use something from the card class, right? Let's say I want to make an object. The way to do that would be to do card.card like this. So if we want to make a card object, let's just call it a king. We do card.card because we're referencing information from the card module and we're using the card class within that. Now doing this is kind of tedious because every time you need to reference information from the card file, you're gonna have to do card dot at the start of it. So a way to get around that is you can do import card, you can do from card, import card. And that, obviously that uppercase C denoting that we want to import the class card. So here, now we can just do card, and it's gonna reference that card keyword, or that card name as compared to the card, you know, instead of having to do like card.card, right? Still works, but a little bit less tedious and verbose. And obviously you see PyCharm automatically imported it for me. So most of the time with imports, you don't really have to worry about it. If in the case you're not using PyCharm or some other IDE that does it for you, it's always good to just do it yourself. And I also want to point it out here that if you hover over stuff that has a docstring, you can see what you put in that docstring. So if you remember, I wrote this creates an instance of the card class and sets the card's attributes. That is the same that I wrote right here. And then what you're also going to see is when I go to instantiate a card, I can hover over it and you can see exactly what we have to pass in to assign stuff to that card object. And now comes the idea of the method signature. And the method signature basically denotes, of course, the parameters as you would be familiar with, but it doesn't denote necessarily, or there's something specific or unique maybe to Python to compare to other languages where you can specify what types you want for each of the files, or each of the, well, it's unique in Python because Python's a dynamic type language. So you don't have to worry about, you know, types. You can just say thing equals 1, but you don't have to say, you know, something like int thing equals 1. So here you can specify what types you want in using what's called a type hint. So when you do a type hint, it would be colon and then the type you want. We'll go and add those here in a second. And then, of course, you have this arrow notation, and what this tells the user of the method is what the return type is. So in this case, it's none, which is the same as null, like in C, because of the uniqueness of the init method. But that can be anything else. So it can be anything. You can set it to be, well, not specifically for this, but for other methods that you define. Since this one's always defined, there's some inheritance and object-oriented programming reasons for behind that. But basically, this is how you can define what the type of the thing you're going to be returning is. And then you can also see here the params thing, which is from our docstring. So this is, again, what we wrote. Color is color of the card, rank is rank of the card, suit is suit of the card. So that's a little benefit there with writing docstrings, is you can kind of, you know, when you have many files, or modules, I should say, it can be hard to remember exactly what everything does. So let's say that we want the color to be a string, so we can just say str, which means string type. The rank we want to do is an integer, and the suit we want to do is a string. That is how you type hint something. So this means now if we go over to main and we hover over card, you can see we want a string. The color should be a string, the rank should be an integer, and the suit should be a string. And we can add a return, which always goes before the colon, not after the colon, before. And you just do arrow, and then in this case none specifically, because that's how the init method works. However, we can do this down here, where in this case the color is a string, right? We're going to set as a string, so this is going to return a string. The rank is going to be an integer, so this is going to return an int. The suit is going to be a string, so this is going to return a string, right? In this case, these all return nothing because, 12. They're setters. And we can type hint these inputs because, well, you know, we could do the same thing we did up here, down here. So this is going to be a string, this is going to be an int, and this is going to be a string. So this, again, when we use these functions later on, we'll get to see this information, even if we don't have a doc string like we have here. So yes, like I said, if we were making a king, we could have the, what's the first element? You can hover over it. It's the nice thing about having that color. Let's just say it's red. And the suit of a king is, you know, you got 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be 9 things. So actually, we can go ahead and define that in our card if we want to, what everything looks like. So we can do this globally just to make it simple. Let's just do ranks. And here, what we can do is reference, we're going to make a dictionary, right? And what we can do is make a dictionary of all of the type names, I should say rank names, and correlate them to some type of number, right, that we want to store. So let's do ace, or let's just do 2 is going to be 2. Make your anything there. 3, 3, 4, 4, and so on. It's complaining here because I didn't do the PEP standard. So PEP is like a coding style, and we can just have it reformatted so we don't have it complaining. But of course, depends on what type of style you're coding in. We'll just have it fix it really quick because that's how it likes it. And obviously, we can define anything here, you know, that we want to use as a some key to some value. So in this case, we're using a string as the key and a number as the value. I happen to start them at the number representation of the, you know, word, but we could have started it anywhere, of course. And another thing you might know is that now we want to get access to that information, but we can't because we're not importing it properly in main. So what we can do is we can just write a colon here and then do ranks. And that will also import the ranks dictionary that we just put right over here. So, for example, now we can just use ranks. Well, I guess, yeah, it would be ranks. And then we can do king, and that will then, you know, look up the key for what king is and output the value of the king that we set, which is 13 in this case. Okay, so that is sort of a quick dictionary lesson. It's always better to use dictionaries when you're doing, you know, information that doesn't need to be easily appendable necessarily. So what that means is, like, if we did something like a list, just say L is a list, right, which is these brackets here. A list is easy to add stuff to. However, you need to, you know, if we have 1, 2, 3, 4, 5, 6 here, it's easy to add things to by just doing l.append. That's the key. That's the method for appending to a list. We can just do, like, you know, in this case it'd be 7, and that would then be put on the end of the list right here. But when it comes to figuring out, like, what some information is relative to something else you want it to be, it's very hard because you need to somehow make a you know, a set or something along those lines where something is correlated to another thing. So, you know, another way to achieve what we did here with this dictionary is we could do, a list, and then we could have sets. However, this is really slow because when we want to figure out, for example, this would be 2, and then we could have this be 2, and this would be 3, and we could have this be 3, right? But this is very slow because if we wanted to get, what the correlation is between here, we'd have to iterate through and check if our key, in this case, we were using king, corresponds with the key we're interested in. Whereas here, it's just a quick lookup. So it's the difference between doing something that's linear time versus, closer to constant time here, because it just searches and looks at the keys and say, okay, that's the one we want, that's the value we want. So we're going to do it in the form of a dictionary. Okay, so now what we want to do is let's start coming up with we have our cards here. Let's start coming up with the notion of the actual game itself. So let's make a deck of cards and let's randomly distribute them between the 2 players, and then from there we can determine who goes first. We can just flip a coin and we'll have we'll play against the computer. So first thing we're going to do here is let's make the main method again. And remember what this is these are special keywords. So these are always defined. The underscore is denoting a key, not a keyword, but a special, variable of some kind. It could be a method, could be, something like that. In this case, when we're running some file, it's going to check for this first. So we always just call it the main method. So here, let's just, get this set up. The pass keyword is sort of nice if you want to just basically say skip this, so let's set up a function in here called create deck. Notice that we're not going to use the self keyword because we're not within a class, and we're not also going to prepend a underscore like we would when we're in a class, because this is just a public method. So here, let's do a list of cards, and that will be what we store in the game. So I'm actually coming up with this on the fly, so forgive me if I change up. I think actually what we might do is let's just make a class and we'll call it game state. And then in this class, we'll do a init, and we'll just leave this empty, basically. Or what we'll do is we'll do self.deck equals none, and we don't have to use anything that's necessarily passed in. We can set them manually, of course. It was complaining at me because there was not enough spacing here. PEP says there must be 2 spaces between a class and any import statements. So our deck may be that. We can do turn equals, we'll just say 0 is player 0 and player 1 is 1. Well, actually, we might make a class later on to denote what a player is. And let's see here. We can do self.turns, and we can just store that as 0. And this might be like, how many turns the game has taken so far. And what else do you have in war? You could have wars. We're not going to implement that. We're just going to have basic card game functionality where the person who wins wins and the person who doesn't win does not get that card. And if they're tied, we're just going to randomly assign them just for simplicity's sake and not coming up with all the rules and stuff behind war. So what we might want to do here is also have, a function, I should say a method called create deck. And let's make instead of making this none, let's make this a list, because we're going to have a list of these decks, or a list of cards, essentially. This will be a list of objects. And you could use another module, or excuse me, you could use a package like NumPy to represent this as an array. An array and a list are functionally the same thing in Python, especially when you're talking about NumPy arrays. And actually, let's go ahead and do that just so I can show you how to import a module and all that kind of cool stuff. So if you look down in the bottom right, you're going to see your interpreter that you have selected. So in this case, I'm using Python 3.9 and war is the name of the project. And you can see when I hover over it, the current interpreter is stored at our current working directory .venv bin python. We can click this and we can select our interpreter and go to interpreter settings. And this is where we can add packages really easily from PyCharm. We don't have to do anything on the command line. And this will automatically add it to our virtual environment that we're currently working in. So these will typically always, these packages will always be here, wheel, and they mean various things, but it's not necessarily important. Here we can press the plus button to install something, and let's just type numpy, and let's just go ahead and install that. We can also specify a version here if you want to use a specific version, not necessarily that important. And we can do install.py or install package. That should install. We can close that, and you can see now this is numpy here, and what our version is inside the interpreter menu. Here's also where you can change, this is basically just bringing you the settings menu, of course you can see at the top, and specifically directly to our interpreter settings, but you can also change key bindings and other stuff about what your IDE looks like, and linting, meaning like what, if you have a coding style error, all kinds of fun stuff here. And you can set up like build tools and all this other kind of interesting stuff like the debugger, if you want to do that here. And there's a lot of settings. It's a very advanced IDE. Another way that you can set up installing dependencies, aka packages, is you can make what's called a requirements.py file. Let's just do pass right here so it doesn't keep giving us this error. So I'll show a way to do that. You could do new file requirements.txt. So that's going to be what the virtual environment will look for when it comes to installing packages. So here it says we already have some packages installed, and it will just automatically dump them. So let's just press that, and I guess it's going to put them there. Yes, I guess it's complaining because I probably have the file already made. But a way to do this is really simple. You just do, like in this case, numpy, which is what we wanted, and if you want to specify a version, you can do equals, which is called a strict definition of 2. I think it's whatever we had, 0.0. It might be different. Let's check really quick. Remember down here, interpreter settings, and yeah, we have 2.0.0 installed. If you want to do like a loose equivalency, you can do, I think it's like this actually, or there's some different ways you can do equivalencies here. Most of the time you just do a strict definition, meaning like when you install this, make sure you install 2.0.0, regardless of if it's new or old. You can also just not write the name like this, and it'll just always install the newest version of NumPy or whatever you have installed, whatever you are requesting to install. And when you open up a new interpreter, you open up a new virtual environment, it will many times ask you, hey, we see you have a requirements.txt file. Do you want to install the dependencies you specify in the requirements.txt? So this is how you can have this set up. So generally, if you were to open this in the command line, you could do something different than using so if you're on a different platform, let's do this. And I'm just going to show this here just so you understand what I'm saying. If you are on a platform, maybe you're on a different editor, maybe you're in the command line itself. Let's go ahead and change directories to where that was. It was in war, right? And you can see here, there's our requirements.txt file. Make this a little bigger. This, allows you to really easily install the requirements that you want for your, your project. So if someone is using it that is not you, they don't have to be using PyCharm in order to install the requirements. They can just install them from the command line. So I'll show that really quickly. Here I'm just going to make a virtual environment really quick. And you'll see now we have this virtual environment. I'm going to activate it. This is different if you're on Windows. And here you see I have it activated. If it's on Windows, it would be something along the lines of, I believe it would be the name of your virtual environment, scripts, activate.bat, so a batch file, and that would activate your batch file. I'm not on Windows though, so I did it the Linux way. And then so now it's just as simple as doing pip install requirements. Well, you need to specify recursive-r, which means install all of them, and then you just do requirements.txt, and now this gives them a very easy way of installing all your dependencies. Don't worry about this, I'm just using an old version of Python and pip. So this would allow them to easily install whatever you specify in your project without needing to use the PyCharm IDE. So I'm just going to, if you ever want to get out of a virtual environment, it's deactivate, regardless of what platform you're on. And I'm just going to remove that directory really quick and exit out of that and go back to PyCharm. Okay, so that's a little sidebar when it comes to environments and also when it comes to installing certain dependencies you want. So now that we have it installed and it's in our path, in our interpreter settings, we can now just simply reference it by just doing import numpy, and now we have all the functionality of numpy, right? You can also import it as another name. Most people, the general wisdom is to use np. It's just a shorthand. Most people know what np stands for, in this case numpy. And let's make an array, a numpy array. So functionally this is pretty much the same, type as a list like we would in Python, like this, but it doesn't necessarily need to, it does basically the same stuff and a little bit of extra. It can be nice for certain applications. And another thing to note, if you ever need to look up certain information about a package, you can just go to PyPy, and now we're here, and you can just do like numpy. That's going to bring up numpy, and you can always look at the documentation. Typically, here we go, it's listed right here. This will bring us to the numpy documentation. You're always going to typically want to do API reference, and we can look at array objects, for example, and all the fun stuff when it comes here to making an array. The idea of a data type object. This is specific to NumPy, but I just wanted to show you, like, when it comes to making an array, this is how you do it, and you can specify, stuff that's inside of it. You can do multi-dimensional arrays in NumPy, or I should say matrices, which are represented as lists. And this, you can just read the documentation, figure out what they do. So always helpful. And here we're just going to make an empty list for now. And all the same list functionality, like I mentioned, still works on NumPy arrays. So here, let's just use self.dec, and we can do, I believe there is, how would you add them? Of course, this is when the documentation comes in handy. Well, to mitigate my lack of knowledge when it comes to, NumPy, because I don't use it very often, if it ever, I'm just going to use Python list. But I wanted to show you the idea of installing a dependency. And NumPy is specifically really fast for doing a lot of data calculations. And a lot of the stuff is the same as MATLAB. So if you're familiar with MATLAB, That's the way to go. So I'm just going to remove this, and we're just going to do a normal list so I can just show you the basics. Here's the append method, which, like I said, just puts it at the end of the list. If there's nothing in there, it'll just put it in the list. And let's make a card object. And we're going to specify that we want the object to be, something, 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 or we can just make our lives easy and use a for loop. So this just means, give me numbers 1 to, 52. Or I should say 0 to 52, or 51, I guess. I think it's 0 in text. My lack of certain basic Python stuff is coming out, of course, but we can always check by just printing I. And we can make a, what is it complaining about? Oh, no worries. We can just make a game state class really quick. And call gs.create. Did I not name each other correctly? Create deck. What's going on here? I'm not 100% sure what I did here. Let me figure this out and then I'll come back. Okay, I was just stupid. I did nothing wrong. I literally was just being thrown off by the fact that PyCharm was giving me some some squigglies underneath it. So we can always just run and see, oh yeah, this is the numbers we get, 0 to 51. And of course it's going to run the main function as we specified here, and we're using the main module configuration. So there is always there's 4 suits, and each of them will have different colors associated with them. I think I might remove the colors thing because it's sort of useless in the sense of the actual information here, so I'll just remove that really quick. And remove that here. So let's just go based on suit. We can do another for loop here. There's going to be 13 cards within a specific suit, and yeah, I mean, we know what the numbers are here, and since we're starting at 2, we can just increment that number. So let's just do self.deck .append. We do card, and then the first element of the card is going to be the rank. So, of course, we already know what the rank is. We have that defined here. And the suit will just be basically whatever value. I think we have the suit as a string, right? So, sort of need to flip these around, unfortunately. Let's go ahead and do that. The little trick I'm doing here is you can hold down Option on Mac OS, or you can hold down Alt on Windows, and it will allow you to duplicate your cursor. So you just keep it held down, and we can go ahead and quickly make some work. Of course, I've screwed this up. And then we'll just fix our work really quick. And we'll go ahead and save ourselves the effort. And we're also going to add a colon at the end. This would be something where certain text editors like Vim, Emacs, or those other ones are much faster because you can do these operations in parallel. So we'll just call this 1, this is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we'll fix our spacing issues really quick. Oh, actually, I forgot. Pep doesn't like that. So there we go. Now we can just use our name ranks thing here to basically translate the rank. So we'll just do ranks J, and that will give us our rank. And there you go. Now we'll have, what we might do here is we'll do this as a string and we'll translate these. So suits. One will be, I guess, I realize we'll have to add 1 to this, so we'll just do +1 because that's going to be 0 indexed. And we'll +1 to this as well. We'll do suits I +1 just to, because we're doing 1 indexed. 1 will be spades. 2 clubs, 3 hearts, 4 diamonds. Yeah, and that'll work just fine. We'll need to import that, of course, suits. And that will set up everything properly, and we'll change our type hint here. Because we're not returning an int, of course, we're returning a string now. And we will fix this to be a string, and that should set everything up properly again. So now we have that all set up, and we're making all of our decks. And we should be able to, loop through all of them and print them all out. Or we can use the debugger, and I will show you how to do that, because that can be very, very, very nice for looking at certain information as the program is executing. Debuggers are extremely useful. You need to use them. Don't use print statements, if at all possible. So let's set a breakpoint here. You can hover over the line numbers to set a breakpoint, and this means if this code line is hit when execution is happening, stop execution, and we can view certain stuff about the code. So we'll hit the debugger key, and of course this runs really quickly because there's not a lot going on. But you can see here our I is set to 0, our J is 0 because, we're on the first iteration of the loop. And we can look in the self keyword to see all the attributes, and we can see that our deck list is currently empty. And you can use hotkeys to go through these. I'll just click them here, and you can see we're filling up our deck down here, and our variables are moving. So if you're unsure about what's going on in a function, you can always use the debugger, and of course we can even zoom in more and look at what's deck 0 here. Well, it's the 2 of spades is specifically, I did not mean to do that. It's the 2 of spades specifically for the first card, the 3 of spades, 4 of spades, 5 of spades, etc. And if you're trying to look at specific stuff without scrolling through all of these, you can use the console and type it in, like self.deck. And that's going to look at the deck, and it's going to use self in whatever context wherever you stopped executing. So it's going to be using this self context, aka the game state object, or you can use in the threads and variables context menu and do self.deck, and it will pull up the result at the very top here. So yeah, so we can see that that's all functioning properly. Let's exit out of that and stop our break point. Okay, so we have our deck. And now what we want to do is randomly select who gets what card. So good idea to just look up, there's a random module in Python, very easy. Looking up things is just part of what you got to do There's not enough time in the world to come up with everything you could possibly know about a language. So, we have to look things up in order to mitigate that. So here we can set a seed, and we can use that as our seed for our pseudo-randomness, because computers can't generate truly random numbers. And from there we can use that to generate who gets what. And yeah, like I said, we can see all of the information going on about the who gets what, essentially. So here we go. What we'll do is we'll import the random module, which is a standard module. Don't need to install a package for it. And I don't know what I'm doing here, typing what I'm saying. And then we can use that to deal cards. Deal cards. And from there, we can use that to, give the cards to certain players. So this is, what is left in the deck, and we can also do certain ways to see if that is being used or not. But let's come up with the, the idea of a player really quick. So let's make a new file, player.py, and you see that the drill. Here we'll make a dictionary. To indicate what the player type is. And we'll use that down here. Also, another thing that's sort of nice is the idea, if you don't want to pass in a value, you want to have a default value in case nothing's passed in, you can do equals here and type something. Actually, I believe it's after this, like what you see here. I guess they want this. Yeah, so this will be like, hey, if we don't get a deck, but we want to, like that, that's a naming issue. We want to, still use this variable, we can just, assign a default value. So we'll just do that just in case. In our case, we wouldn't do that, but it's nice for people who may be using your code who's not familiar with it. So now we have like a deck class. Let's fix this formatting issue, and that fixes everything. And we can just, of course, do like add card. And then we can do card. And this is going to return nothing. Let me do self.play deck.append card. And we may want to remove a card from the player, right? So let's just go ahead and remove a card and return it as a type. So let's just do self.deck.append remove, and then actually might even be a pop. Yeah, pop. So this will just give us whatever is, I believe whatever is on the front of the list. Return. Defaults at last. So this is a nice thing, you can hover. So it's going to pop off the last card in our deck, and we can just return that. There you go. So this will be our simple little player class, and we'll do self.computer equals computer, and we can also, you know, or sorry, I don't mean computer. We have to import it first of all from player, import player, and we're also going to want to import PT, which is our player type. Player, and the first thing is the player type string, so we'll do PD computer, and our deck is currently empty, so we'll just pass in an empty list. Yeah, sorry, it's PT, not PD. And then we want to have a human player as well. There we go, so we'll have empty decks, and we want to deal our cards, so, you know, let's make a method that will take stuff from our deck and we'll assign them to each player. So let's do something like this, where we first seed our random, so random.seed, and then let's look really quick at the documentation and see what we get. Random int probably sounds like something we want. We can just do something between, you know, 0 and 10. So rand equals random.rand int, and we want something between 0 and 10. And here we could do like if rand is greater than 5, then give the computer the card. Well, I guess we have to give them individually, and then maybe we give the player the next card. Yeah, that's how we'll do it. So we'll do, and we got to get a random card from our deck. So that's pretty simple. We'll just go ahead and do self. So this will be, you know, computer gets the card, else player gets the card. And let's do card number. So card number equals random.rand int, and then we can do 0 to the size of the deck. So we can do len, which is the keyword method for figuring out the length of a list, and do self.dec, and that should give us a number between, I believe it, yeah, including both endpoints. So that's important that len, we want to do -1 because it's going to be not 0 indexed. So that'll give us a card number, and we'll go ahead and do self.computer.add card, deck, self.dec dot remove card number. What is it saying? Oh, sorry, pop. That'll give us a card. And then we can go ahead, and that means that the computer got to choose first, and let's give the next card to the other player. So we can just do the exact same thing here, and what we could do, in fact, just to, it's less readable, but we don't really care right now, do we? We can just do this here. This is a terrible, don't do this, but it's just a shorthand. You can always do something like this to make it a little bit more readable in the case that you're doing some stuff like what you're seeing here. And you can always do something like this to make the function, or the use of the method in this case, a little bit more readable. There we go. And this, in the other case, we just want to do basically the same thing, but we want the computer or the human to get the thing first. And then what we'll do is we'll just do a little while loop. While self.dec, or I guess be while len self.dec is greater than 0. We'll add that, and then let's see if this all works. gs.dealCards, I believe that's the name of it. And then let's do a print, something we can just use as a breakpoint. Put that right there to see what the program looks like after we have finished this function. So let's go ahead and run that with the debugger. Okay, so we get an index error. What did I do here? And what did I do? I passed in, I understand. I wanted this to be the other way around, I guess, in hindsight. So this will be a 0, this will be a 1. Yes, PT. There we go. Now let's just stop and rerun it. Self is not defined. That's just the debugger being stupid. That's because we put a watch point. Don't have to worry about that. And now let's see if we have anything left in our deck. We don't. Good. And let's check our human and computer decks and see what we got. So this one had the 9 of diamonds, 3 of diamonds, 3 of hearts, ace of diamonds. And it looks like this has 26, 0 to 26, or 0 to 25 is 26. And this one also has 26. Very good. So now we have distributed the cards equally, and that's looking good. So the next thing we want to do is actually play the game. So let's set up a way to do that. Def play turn. The reason this is not highlighting is because I don't have this the correct scope level. There we go. So first thing we're going to do is, if it's 0, it's the computer's turn, or if it's 1, it's not. What we might want to do actually to make this a little bit more fun is let's just make a number random int between 0 and 1, and then we'll use that to figure out who is going first, and then we'll just alternate between the two. So we'll seed our stuff up here. And we'll just do random.randint 0, 1, and then it'll give us who is going first and who is not. Let's stop the debugger. Okay. So, while, the way that war works, of course, is that it's while one player has, still has while both players still have cards left, the game keeps going. So we'll just do a while statement. While self dot human dot deck, do len of that, it's greater than 0, and len self dot computer dot deck greater than 0. This means there's still a valid play. Well, first thing we want to do is figure out whose turn it is. So if self dot turn equals 0. This is a computer's turn. And the reason we're going to do turns is because, I don't know, I felt like I'm going to make it a little more interactive. So we'll do that, and then else, because I know that, of course, each turn is just putting a card down. And we'll do human's turn. Cool. So in the time that we do a human's turn, let's figure out. Let's write a stub function which determines who has the higher card. So this will be pretty simple. Def determine winner card. Maybe we do card winner, and we can just pass in the two cards that we draw. So we can do human card, and then we can do computer card. These are card types. We can do if human card dot rank is greater than computer card dot rank, return. Let's see, how do we want to do this? We'd want to determine, well, what we can do actually, we can just give the other player the card and remove it. So we'll do we can do a way to just find the card and figure out what type it is, and then remove that from the other player's deck and then return it, essentially. So what we could do is just do something like this in our player class. We could also just do def remove specific card, and then we can do for card for C in self.deck, if C equals self.deck, or basically, yeah, if card equals C, self.deck.pop, we need to know the index, I guess. Sure, we'll do it like this. If I in range len, right? We can do self.deck I, and we can just pop I off and return it. There we go. So a little quick function there. And we can do, if that one's greater, the human card is greater, that means that the computer's card needs to be popped and given. So we'll do self.computer. Remove specific card type, or I think it's card, correct? Yeah. We can do computer card, and we can just add that to the human cards, right? So self.human.deck.append, which we'll put at the end. I guess we want to put it at the front. I think, is there a push method maybe? We can look that up, of course. Python list put in front. Let's see. Insert. There it is. Simple as that. Insert. We want to put it at 0, and the thing we want to do is self-computer remove specific card. We're going to remove that card and then put it at 0. Else, we want to do the exact same thing essentially, but we want to do computer and remove human card and human. There we go. You know what, actually, I'm gonna change what we got here. I'm just gonna make it go real quick. We're just gonna play against two computers. We're gonna have two computers play it out. It'll be easier. We'll get to an end product faster. And we're gonna remove the idea of turns because we don't really need them anymore. Yeah, we'll just do this just for simplicity's sake since this is getting long. So basically what we'll do is we will pull a card from each player. We'll do human card. Of course, it's not the right name anymore, but that's okay. We'll do self.human.remove card, computer card, self.computer.remove card. And then we can do self.determine card winner and do human card and computer card. And that will then put it in, you know, who wins what, and maybe what we want to do is just to give the person who's playing, you know, we can give them an idea. So we do self.turns plus equals 1. That'll tell us what turn number we're on. So let's do print. You do a format string here, just kind of like C. We can say human card. I guess it'd be more computer number 1 card. We can do human card, of course, forgive the names. Rank, I don't believe, are those numbers? No, they are strings. Cool. So we can do the suit and the rank. So it'd be a of human card, dot suit. Spelled that wrong. So basically, this is how you can put in information into a you know, something here. You can also specify something and then do it afterwards like you would in C and type the individual variables themselves. And we can also do print. Same thing. Number 2's card, we can do computer card, and we can then do, we can do a little simple check here. This will figure out, we can figure out who has, how many cards they have left and who won that turn. We can do if computer card num is not equal to whatever the length of the thing is now after the change has happened, then that means that, or I should say, if it is greater or less than this means that if it's less than, that means it lost a card, so that means the human one, or computer one, I guess we should say, number 1 wins this hand, and otherwise your 2 wins this hand, and there you go. We can then print how many cards they have left. Computer number 1 has, I guess we don't even need to do that, do we? Has cards left. And we can do the same thing for number 2. There you go. And then, at the very end, did I mess something up? Ah, yes. Forgot my leading point there. My leading underscore. So now, what that'll do is play until both the players are done, and what we can do is we can also make it not go instantaneous by importing the time class, or method I should say. Well, I guess it is class, and we can just wait a certain amount of time. So we can just wait 1 second between each turn. Actually, we can do like maybe 0.5 a second so it goes faster. So it'll stop the process from running, so we can actually read it as it goes down. And we can also do something like we do input. This allows you to take in input from the command line. We can do that way as well. Maybe we'll do that to start, just to see what each turn is. And yeah, then we'll finally determine who won by just checking whose length is equal to 0. We'll do computer. And if that's not the case, we print that computer 2 wins. So now we should be able to play turns, and let's just see what happens. gs.play turns. Oops, did not mean to do that. Go back to our browser over here. We can also just close it by doing that too. And yeah, let's go ahead and it's always a good idea to just put a debugger step where you're gonna, new functionality just added, and make sure it all works, and step into it. So, of course, that should go through. We're on turn 1. Let's remove a card from each player, and let's see what they have. So, it looks like computer has 5 of diamonds, and the human has a 10 of spades, so the 10 of spades should win. We can see this printout, right? So we have, I guess I messed that up. Of course, this is why you just go ahead and do this kind of stuff with the debugger. Very easy to figure out where errors are. You should always use a debugger and step through new code you just worked on. We were just there last, so we'll go ahead and just stop our debugger there. There we go. Jack of diamonds, 9 of diamonds. So the 9 of diamonds should win. Let's go ahead and see. So let's look at our variables and see what has changed. $25, $26, and the computer had, yes, 9 of diamonds. Is that correct? Let's see. So human is equivalent to player computer 1. Jack should win. Let's see what the issue is here. Oh, I think actually we're all good. I think we're adding it incorrectly. Let's see here. That looks all correct. course, what we can do is just hit the the input and see who wins. So I'm just hitting enter. Computer 1 wins this hand, except for they're losing cards. Ah, I see what's going on. So the issue is that we are inserting them and removing the element that's at element 1. So what we can do is when we remove something from the deck, we can just pop off the first element, and it's just complaining because there's no new line. Not a big deal. And now when we should just append to the end so that we're not grabbing the card we just got. And that should work, and then we just append. Now let's go ahead and do this again. Doesn't appear to be, and we have an issue. No attribute suit. So we're having some issue when we're removing it. It's not actually pulling the cards back up to the front. Oh, I believe I understand what the issue is. So we're popping it. What we want to do is just remove the card. So what we can do is add a breakpoint and see what happens. Well, let's actually just do it in main. So here, the computer card should lose. It does. And let's go ahead and look at the deck here. I believe you can actually move this over to the side somehow. I don't remember exactly how you do that. Yeah, that's okay. So the computer deck and the human deck. Let's see what happened to them after we step once. So this has 26 elements in it. And this has 25. It looks like that worked properly. So it looks like it's adding properly here. And this looks like it removed properly. I guess one thing we can check, we can go back to here. We can hit the input so that we're on our next line. We can look and see what it was. So it was a 10 of spades and a 7 of spades. Should be appended to the end if it got where it was working correctly. Let's make this bigger. It's being added as a none type. That's the issue. So it looks like it's being removed properly but added incorrectly. see. That's why we had the attribute error, where we were trying to access something of a none type. So I'm going to fix this and then I'll come back in a second. Okay, so the issue was the fact that I was not paying attention to the rules of the game, and I was actually doing a disservice to myself by actually double removing the cards. So if you remember, we had a remove specific card method. I realized that I didn't need to do that because I was actually pulling the card off the stack regardless. So I already had the card object right here when we removed them. So all I just needed to do was pass them into the method that we were using to determine who won. And I also forgot that, of course, when you win, you still get your card back as well as the other player's card. So I added that fix, and one thing I was doing in the debugging process was actually made a special method here. The __ equal or EQ stands for if you have two cards, like two things of this type, of this object. If you do like card 1 equals card 2, or double equals I should say, it will then do this operation here. So basically I override the equals operator right here, and you can see right here that little signature, that little icon obviously is saying I override the method in the object. That's how you can make custom methods for specific operations, like using certain operators. In this case it was the equals. We don't need it, but anyways, now the result is we can do input here and we can see who won. I removed that from testing, and then we also, I forgot to print what the current turn is. We can do this up here actually. Current turn. We can just do self.turns. Now, when we do this, you can see current turn 1. Very good. This makes sense. 4 is bigger than 2. Boom. Yep. Everything's looking good. Computer 2 is getting. Oh, everything's good. Yep, everything's looking good. And we can just quit that. And we can maybe do the timer so that it'll just do it every quarter of a second. We can watch it go by. There we go. So now it looks like the game is working properly. And of course we could add different functionality to make different ways. We could have a 2-player, we could have it where you play against the computer and you have to like hit enter or something to see, to put your card down, or we could do all types of things. We could make a graphical user interface and we represent all the actual cards in that way. We can do many different things. We can implement the actual war mechanic of the game. So clearly there is infinite possibilities, really, even on a simple project like this. And it looks like, we thought computer 1 was going to win there, and there we go. So it looks like we have right here the computer 2 wins, and that all checks out because it has 52 cards. And we can also make it go really quick by just removing this and letting the computer do it real fast. Boom. That one took 64 turns. Let's rerun it and see. 84 turns there. Computer 2 won again. Computer 2 won again. So it looks like there's some kind of bias, but you get the point. That one took 106. And so you understand now sort of the flow, making classes, making methods. We have the idea of return types, type hints. You can even do stuff like this you see here. I didn't really mention this, but you can say, I want a list of card objects as a type hint. Default types, making dictionaries, making lists, importing different modules, the debugger, of course. You have the packages and the interpreter settings here. And there you go. So that's the little war game. Hopefully you learned.